We start with our discussion on Unit 4 of AFM, and in this unit we are going to look at variety of schedules of how companies deal with debt and debt repayment. So the debt repayment schedule as well as a little bit of the bond mechanics is what we are going to work here. So what are the kind of various models for debt repayment? How do you model what is called as an amortizing loan? Amortizing loan is nothing but a loan where slowly you are repaying the principal, and because you are repaying the principal, the loans keep becoming smaller. The loans get smaller over a period of time. And just like amortization or depreciation reduces the value of an asset, an amortizing loan will keep reducing the value of the loan, the principal amount as you go along, right? We're going to have a specific focus on EMIs and once again recap what happens in let's say something like a home loan EMI if interest rates change, if tenure changes, etc., and recap that entire discussion. We're going to look at financial modeling for bonds and bond pricing at the later part in this particular unit, right? So let's first begin with models for debt repayment. Let's assume a company has a certain amount of debt and it is supposed to repay the debt. The repayment of debt will include either the interest component and the principal component. Both the interest and the principal component would be a portion, right? Interest is straightforward. There is a defined interest rate that is there in the market, and when a loan is given to a company, there is a defined interest rate that has been created, and based on that rate, technically the interest gets paid. The principal repayment, the part of the principal repayment is not clear unless we specify what kind of model we are using, right? So how much money is to be paid is going to get defined by virtue of the models of debt repayment. And in that context, we are looking at broadly 4 different models at this point of time for debt repayment. So companies that take debt need to create a schedule to repay it. This can be modeled in financial models. There are various ways in which this debt could be repaid, right? The debt could be repaid in equal monthly installments, what is called as EMI, equated monthly installment. Now it could be monthly or this could be yearly as well. The same concept, instead of an EMI, will become an EYI, equated yearly installment rather than monthly installment. In this case, what typically happens is the total installment amount remains the same. The amount of interest and the principal component within that keeps changing over a period of time, right? The second mechanism could be that the principal could be repaid in equal amounts over a tenure. So basically, if you have a 100 crore loan and you have a 5-year tenure, you're going to repay 20 crore each year, right? So that's the second one, which is a standard principal repayment, straight line kind of a repayment uh, of the loan that could be done over the tenure of the loan. There could be a specific customized schedule for a certain loan. That's the third one, where a bank says that for a certain number of years you pay this much and then you pay the, different interest rate or repayment schedule. Similarly, the bank could say that yearly what kind of repayment has to be made. That is there. And finally, there is a fourth one where the debt repayment or loan repayment could be to manage a certain debt service coverage ratio. Now, if you recall our ratio analysis, we had done a discussion about interest coverage ratio, briefly spoke about something called as debt service coverage ratio, but did not cover it in too much detail. We're going to look at that now, where companies might look at how much loan repayment has to be done relative to the cash flow that the company has generated in that year, right? So there are 4 broad models that we're looking at, and we're going to look at examples to try and see how that works. So the first one is equated installments. Under this method, similar to the home loans repayment schedule, an equal amount will be paid, you know, every year. I'm taking a yearly example at this point of time. This would be a combination of interest and principal, with principal being lower in initial periods and then interest being higher, and then over a period of time the principal becomes higher and interest becomes lower as the loan amount keeps going down, right? At the end of the tenure, by making equal payments, we would reach a debt level of 0, right? Now, the Excel functions that solve this, we've already seen, are PMT and PPMT, right? So payment and principal payment for a particular period. This is a function that will use a few other parameters like PV, N per number of periods, what is the rate, and so on and so forth, right? And in this case, the future value is going to be 0 because we are taking the loan amount to 0. The debt is becoming 0 at the end of this entire tenure, right? That's an equated installment scenario. How do we model it, right? Let's take an example. Assume a rupees 150 crore loan taken by a company for a period of 9 years with an interest rate of 8%. Assuming that annual payments are being made for interest and principal repayment, find out the entire loan amortization schedule, right? So the total loan is 150 CR, rate is 8%, and loan is basically going to be the present value in this case, and the number of periods is going to be 9. If we were to convert this to monthly, then we are going to take 8% by 12 and 9 into 12. That's what we did for the home loan essentially, right? Now to solve this, let's go to an Excel file. So let's work around our total scenario in terms of what is the debt. So let's take the principal amount, and that's 150. Let's take the rate. The rate is 8%, and let's take the tenure of the loan, that is 9 years. That's what we have specified so far. Since these are all the inputs, let's create a table around this, and let's highlight these in a certain color, right? And I'm going to format all the number portions here to incorporate 1 decimal point. Now we're going to model this where we're going to say year 1, 2, 3, 4, all the way up to 9 years. We can manually do it. We can also automate it if needed. But in this particular case, we're going to look at only the manual number. So beginning principal amount, right? And the first year beginning principal amount is the same as 150 crore. Then you want to look at what is your payment of the principal, right? So principal repayment is what we mention here. We also mention what is the interest payment. The sum of these two should give me my EMI, right, or the installment. So sum of these two should give me the installment, and then I should have a closing principal balance, right? So the first thing I can calculate without even putting anything is the interest payment. That's going to be 8%, and I can freeze 8% because I'm assuming rates to be constant. 8% of the beginning principal value, right? So whatever is the beginning principal value, 8% of that is my interest. That's 12 crore, right? Now, how do I find the principal payment? For that, I can calculate for the installment. The installment calculation can use a function called PMT. And if we open the functions for PMT, it includes rate, which is going to be 8%. It includes number of periods, which is 9. It includes PV. Remember, PV and PMT have to be opposite sign in this case. So I put a minus and put a 150 there. FV is 0, and we can put this. So the number we get is 24.0, which basically means the installment being paid is 24 crore, interest is 12 crore, so principal should be installment minus interest, right? That should be the principal repayment that we get in this particular case. What that means is that the closing principal should be 150 minus how much have we paid? 12. So that's 138 approximately. 138 is what we get as the final closing principal, correct? So that's basically our discussion around equated installment. Now, what we can do is we can put the next year opening principal as the same as last year closing principal. And since we have equated installments, the installment would remain the same. The installment remains the same, correct? Interest payment will change because interest payment is now 8% of 138 crore. The principal is lower. The principal payment will be the difference of 24 minus 11, correct? Note the principal repayment has increased as compared to the first year because our total installment payment is fixed and interest payment is going down, correct? So we pay more principal the next year. And once we do this, we can just create a standard schedule for the 9 years. And we will realize that at the end of the 9 years, we should end with zero loan because we have amortized the entire loan over this period. So beginning year 1, we started with a number of 150 crore as the principal. The installment being paid every year was 24 crore. We found that by using this formula called PMT. And based on that, once we calculated the interest, the difference between the installment and the interest payment was the principal payment. Subtract the principal from the beginning principal, you get the closing principal value or the closing loan value, and slowly you have amortized the entire loan over this period. That's basically how we go about solving for an equal principal repayment, the equal installment repayment scenario. We can also try and create a small graph around this, which might give us a broader idea on how this is being paid. So what we probably need to do is put years and select the principal and interest repayment. And we're going to insert a chart here. The chart would be, let's put an area chart because that might give us a better idea about what's going on here. Right, so let's try and put an area chart like this and click on OK. Now in your source data, one of the data points which you see has been highlighted. If I select all the data, there are 3 series which are there. I don't want the year series here. I can remove the year series here, right? And horizontal axis labels, I could actually edit this and put the labels as the years, B9 to J9, right? And close that and click on OK. So that gives me again till 9 and I click OK, and that's the scenario. The principal repayment is the orange area that keeps increasing. The interest repayment is the gray area that keeps decreasing over a period of time. And that's how the schedule would look like. That's how basically the schedule would look like. If we go down, we can keep it here on the side. That's basically the equal installment scenario where we have basically paid the amount over a period of 9 years, right? So let's move ahead now and look at the equal principal repayment scenario. Now under this method, we just divide the principal over the loan tenure and repay equal amounts of principal every year, right? So in this case, if we have 9 years, then over 9 years we are going to pay the entire loan. So approximately 11.1% of the loan gets paid every year, right? This way, the sum of interest and principal payment keeps reducing every year. Let's try and solve the same question, and let's try and work that around using our Excel. We can go to the equal principal repayment schedule sheet, and what I can do is I can just actually copy and paste this set once, and let's see where we get there. That's the data we have, right? Now, unlike here, the installment is not fixed. The installment is going to be actually a sum of these two numbers, right? And here obviously there is a circularity that comes because principal repayment is getting calculated from there. Now principal repayment is straightforward in this case. Principal repayment is this divided by the years of tenure. Straightforward, right? And that's 16.7, and that's going to be the same every year. There is no change in that. It's a straight line amortization. So 16.7 crore is going to get paid every year. The interest payment is whatever is left in principal multiplied by 8%. So that's the interest payment schedule that comes out, and I can ignore this error. And the installment is actually nothing but the sum of these two, but we will note that over a period of time the installment keeps reducing. Closing principal again becomes zero, because that was what the idea was in any case, right? That we were going to kind of reduce the loan in a straight line method over this period. So closing principal goes back to zero, but what we see is that the installments keep reducing now. They start with a bigger installment number, but in the previous case we were having 24 crore as the installment. Here we start with 28, but we end with 18, and it keeps reducing because interest payments go dramatically lower, and principal repayment is kind of fixed. Here the first year principal repayment was 12 crore. Here we start with 16. So there's a quick dip in principal that happens under equal principal repayment, right? Just like we did earlier, we can create a chart with this set of data. And when we look at area chart, let's quickly create an area chart with the sort of data that comes here. Click on OK. I don't need this data. So what we find is the principal repayment, which is the orange one, remains constant. The principal remains constant, and I can add the data label here, or I can add specifically what's happening there. The interest repayment keeps going down over this period, right, because of the fall off. And unlike the first case where the total was always constant, the total was always constant at 24, and hence you see a rectangle getting built. Here the top part becomes a right angle triangle, right? So it's not a rectangle that we see in total. We do see a reducing total amount that that happens, right? So that's basically what we are looking at in terms of our broader understanding of the second mechanism of payment, which is an equal principal repayment schedule, right? That's the second one that we have seen. We'll cover the next ones in the subsequent videos. And so as we come to the end of this particular video, couple of quick questions. Assume that a 320 crore loan is taken by a company for a period of 12 years with an interest rate of 10%. Calculate the amortization schedule assuming equated annual installments and assuming equal principal repayment, right? Just what we did. We have to revisit that with a new set of data, try and create this set of data for this particular question. Thank you.